in the second case of trigonometric substitution, the radicand is a squared plus x squared. A is a constant. But if you take a look at the integral I gave you, there is an x squared plus 2x plus 5. So you don't really know that what to do with the 2x. So in this type of problem, we have to do a complete the square. How do we complete the square? First, you group the first two terms. So x squared plus 2x and then plus 5. So just group the first two terms. And then this is a quadratic equation. So let's do this. So quadratic equation, that is ax squared plus bx plus c. Quadratic equation. Quadratic. Since there is no equal, I will just call the expression. What is the graph of this? The graph of this is just a parabola. So x squared plus 2x equals to 5. Do we agree that the b is equals to 2? So in this problem, b is equals to 2. To complete the square, you have to do this step. You have to take the b divided by 2 and then square. So that will be 2 divided by 2 square, right? That is equals to 1 square. I know 1 square is equals to 1, but keep that in square. And then how do we use the 1 square? So to use the 1 square, we do x squared plus 2x and then save some space for myself and then do the plus 5. So to do the 1 square, this is what we have to do. We are going to add the 1 square and then subtract the 1 square. Why do we have to do an add and subtract? If you don't subtract the 1 square, that means you just add an extra quantity to the expression. That means you already changed the problem. So that's why you have to add that quantity to it and subtract that quantity immediately. So by having the plus 1 in there, I can do this. So the next line is equals to x and then plus 1 square. The whole thing square. So if you open up this square, then you will get x squared plus 2x plus 1 easily. And then the 5 minus 1 is equals to 4. So now the completing square is done. So the integral becomes the integral of 1 divided by square root of x plus 1 square and then you plus 4. And then the x plus 1 is just a variable. So this one we are using x squared plus a squared, right? Now follow me. The x plus 1 is, maybe I should shade the whole thing. The x, that doesn't look too good. Okay, the x plus 1 is just equals to x. So this is, x is now x plus 1. And then the a is equals to 2. How do we, so the x, we will just treat the x as x plus 1 and then the constant is equals to 2. And then we are going to let x equals to a times tangent theta, right? So that means x is equals to 2 times tangent theta. Is this correct? The answer is no. We are not using x as x. We are using x as x plus 1. So instead of saying x, we will just do x plus 1. So this piece, I will just take this piece over there. X plus 1 is equals to 2 times tangent theta. You have to do this. Otherwise, the whole thing is wrong. And then x is equals to 2 tangent minus 1. So we have an x, but we are trying to change the integral to dx. Then you have to differentiate both sides. The derivative of tangent is secant square. So 2 secant square theta. The derivative of 1 is 0. So you have a 2 d theta, and this d theta is going to replace, forgot to do a dx in there, is going to replace this dx. So now the dx is done. And then the 1 is just a 1. What about the square root? The square root, you still have square root x plus 1 and then square plus 4. How do we do this? The x squared plus 1. The x squared plus 1 is just a 2 tangent, right? So that is equals to 2 tangent theta. And then you square that. 4 is just a 4. And then you open this up. 4 tangent square plus 4. And then you factor out the 4. You have tangent square plus 1. Tangent square plus 1 is secant square. 4 times secant square theta. So that is just equals to 2 secant theta. So that will be the bottom. And then you put everything together. So first the top one is still a 1, the bottom is now 2 secant theta, and then the dx becomes 2 times secant square theta d theta. And then you simplify that, the 2 got cancelled, and then 1 secant got cancelled, and then you have integral of secant theta d theta. This one you can take a formula. You can just take the formula. This is equals to ln absolute value secant theta plus tangent theta, and then plus c. Are we done? The answer is no, we are not done, because the integral is in x and we have a theta, so we have to put the theta back to x. So how do we do that? Then we have to use the right triangle trigonometry. So let's draw a right triangle first. So this is my right triangle, 90 degree, and here is my theta. So at the very beginning, I let x be what? I shouldn't say I let x be what? I let x plus 1 be this. X plus 1 is equals to 2 times tangent theta. So I'm going to bring this down. X plus 1 is equals to 2 times tangent theta. Then my tangent theta is equals to TOA, right? So opposite divided by adjacent. That is equals to x plus 1 divided by 2. So the opposite is x plus 1, and then the adjacent is 2, and then what is this going to be? So this one is a squared plus b squared, right? So this is x plus 1 square plus 2 square. If you do the math right, this is x squared plus 2x plus 5. So the square root of x squared plus 2x plus 5, right? Remember this? Pythagorean theorem, a, b, and c. We have a squared plus b squared equals to c squared. Pythagorean theorem. Okay, so now the right triangle is prepared. We have to do one for secant and then one for tangent. So the tangent, you don't have to do anything. Just do the secant, right? So the secant, what is that equal to? Still remember this? SOHCAH, S-O-H-C-A-H, and then TOA, right? We use the TOA, and then the secant is the reciprocal of cosine. So the cosine theta is equals to adjacent divided by hypotenuse. Then the secant is the other way around. So the other way around means the reciprocal. So that will be hypotenuse divided by adjacent. Hypotenuse is the square root, right? So we have the square root divided by adjacent, which is equals to 2. And then finally, you put everything together. So what is the final answer? The final answer is ln absolute value. The secant is the square root x squared plus 2x plus 5 divided by 2. And then the tangent, we already have the tangent, right? The tangent is x plus 1 divided by 2, and then don't forget the plus c. This absolute value is not optional, because you cannot guarantee the addition inside is positive. All right, so that is the answer to the given integral, and that is also the end of this video. If you think I picked the best video for discussion, especially I just review the completing the square for you. Oh, by the way, speaking of completing the square, I want to give you another example. So how about this? What if the completing the square is x squared minus 10x? So let me do this before I end this video. How do we complete the square? So this one is ax squared plus bx plus c, right? So the b is equals to negative 10. And then you have to do a b divided by 2 square, b. So that is negative 10 divided by 2 square, which is negative 5 square. How do we use this? So here is how: x squared minus 10x. I am going to add the extra piece and then subtract the extra piece. So add this and then subtract the same thing. So that means I didn't change the problem at all. So, and then you are going to consider the first two. Why do I leave the negative 5 in square? Because I am going to bring the x and the red number inside the parenthesis, which is negative 5. and then put the square outside. So if you square this out, you are going to get x squared minus 10x plus 25. And then the other one, the other negative 5 squared, now you can square that, so that is equals to minus 25. So that is how you complete the square when the b is negative. Alright, so now this is officially the end of this video. Subscribe to my channel, like the video for me, share the video for me. See you all in the next integral. Signing off for now.